Hello, we're continuing on the video lecture series on Chapter 5.2 from the Lock 5 textbook. All right, we finished on the slide before this, looking at moving from the bootstrap distribution idea from Chapter 3 to the new smooth curve normal distribution concept from Chapter 5. Two different ways of getting confidence intervals should give you very similar confidence intervals, not the exact same. So from the last video lecture, series 5.1, we looked at this z-score or standardization. And the idea is this puts everything kind of on the same plane. How far is a data point from the mean relative to the spread of that data? So let's undo this formula. If we wanted to undo this formula to unstandardize, if I wanted to solve for x, then the first thing I need to do is multiply both sides times the standard deviation. So here, if we multiply z times the standard deviation, then on the right, that standard deviation will cancel out. And then again, if I want to solve for x, I would need to add the mean to both sides of the equation. Add that mean, and I'm going to get x equals the mean plus z times the standard deviation. So in testing, we go to a standardization statistic. In confidence intervals, we want to find a range. So it's a minus z star to a z star. I'm going to keep talking about this more in a little bit. So we want to find a range for a standardized distribution and then return to the original scale. So this weird thing, we standardize and then unstandardize. So it's the reverse of those z-scores. We did a lot of in the last chapter. So again, solving for that equation we did on the previous slide, x is equal to the mean plus z times the standard deviation. So what's the equivalent for the bootstrap of the distribution of the statistic, the bootstrap distribution? Here, we did this as the mean, instead we would take it as the statistic. Instead of plus z, we're going to say plus or minus z star. Again, I'm going to come back and talk about what the z star is. And then instead of standard deviation, we're going to place that with the standard error. But it's the same general formula. Your statistic, plus or minus, we called this 2 before. We're going to be a little bit more precise in Chapter 5 and call it z star and then times standard error. So if we take a p% confidence interval, so keep in mind in the Chapter 3, we only did 95% in the middle. In Chapter 5, now we can make this any percentage we want. What would change is the z star. What z star is the cutoff. Z stars are the cutoff that give you the middle 95% in the standard normal distribution. So z star and minus z star capture the middle p% of, this is the normal distribution with mean of 0, so the center 0 and standard deviation 1. And then we're going to return to the original scale to take the statistic, whatever your sample statistic is, plus or minus the z star, and then times standard error. And this is going to be the formula now we're going to use. It's very similar to the formula in Chapter 3. For confidence intervals, the only difference is in Chapter 3, the z star was always 2. In Chapter 5, we're going to be able to change our confidence level, which will change this z star. Okay. So how do we find a z star for a 95% confidence interval? Okay, I want to go to StatKey. So I'm going to go to StatKey to show you how to do this. How to get a z star for 95%. Oh, sorry. So here, look at StatKey on the main page. So if you want 95%, you go to StatKey, and that z star means go to normal. You want to make sure the mean and standard deviation are 0 and 1. So I don't want to change the parameters. Back to the last slide. Z star means we keep the mean 0, standard deviation 1. Click on two-tail. Anytime you do a confidence interval, you're always going to do a two-tail test. Make sure this middle entry says 95%, 0.95, which it will, as the standard basically for this. Click on the standard setting, I should say. And here on the bottom, so you see a plus and a minus, the same number, 1.96 minus 1.96. This is your Z star. So again, going over that idea again, we want to make sure we're in the normal distribution, centered at 0, standard deviation 1. Make sure that middle says 95%. And then down here, that is Z star. It's the value that cuts off the middle 95%. And so what were you doing in Chapter 3? That 95% rule from Chapter 2 and 3 is just rounding this number to 2. So 1.96 is close to 2. So to do a 95% confidence interval in Chapter 5, we're going to be just slightly more precise and change that 2 to a 1.96. Let's go through an example. So if we want to get a 95% confidence interval for the honeybee waggle dance, and the sample statistic is the difference of the sample means, 60.49, we just got Z star from the standard normal distribution to be 1.96. That's for that 95% confidence interval. And then the standard error from the bootstrap distribution was 16.38. We're going to use the formula, the statistic plus or minus Z star times the standard error. Take 60.49 plus or minus, and then take 1.96 times 16.38 and subtract and add, and we get 28.39 to 92.59 to get our 95% confidence. So again, think about big picture. In Chapter 3, we just looked at these bootstrap distributions. 95% of the samples, bootstrap samples in the middle. Then we could replace that with a smooth curve. Remember, in this one, we had to change the center to not be 0, but 60. And enter in the standard error to get the confidence interval. And another approach, and this is the most standard, this is the most common, is to figure out your Z star using the normal distribution, 0 and 1. And then unstandardized to go with your statistic, plus or minus Z star times standard error. So notice in all three of these, we don't get the exact same confidence interval, but very, very close. And as an interpretation, what do these two numbers mean in context? Wrote a little explanation. Interpretation, we are 95% confident that honeybees do between 28 and 93 more circuits of their waggle dance, on average, for high as opposed to low quality nesting sites. So those little bees move around a lot more, or do a lot more circuits when there's a better site. All right, so like I said, in Chapter 3, we only did those 95% confidence intervals. Now we have the power, with this new theory, to come up with a 99% confidence interval. All right, so I want to go to StatKey. I want to show you how to get this on StatKey. I encourage you to pause the video and open up the StatKey window. Click on the link, or you could just Google StatKey. On the main screen, click on that normal distribution. And for figuring out Z star, you do not need to change anything. The mean should be 0, standard deviation 1. For confidence intervals, always click on two-tail. And now the only difference is we don't want 95% in the middle. What do we want in the middle? 99%. 99% in the middle. So click that center option, make that 0.99. Click OK. Down here, notice on the side, I have 0.5% in each extreme tail, 99% in the middle. And then down here, I have minus z star, and then here's z star, 2.576. All right, take a screenshot. Oh, that's interesting. Different rounding. Okay, this should be 576. Anyway, I'll have to look into that, what stack he's doing here. But it'd be 576. And at the third decimal, we won't stress about that too much. But z star is about 2.576. I'm going to write 76. So if I want to create a 99% confidence interval, this setup is still the same for those honeybee waggle dance. We have a sample statistic. We have a new z star, 2.575, and the standard error is 16.38. So here, take the formula statistic plus or minus z star times the standard error. We're going to take the statistic, 60.49, and then add and subtract to get the interval, 2.576 times 16.38. Throw this in the calculator. You get 18.31 to 102.67. So notice right here, the larger the confidence level, the larger your interval. And hopefully that makes sense, because if you're doing a 99% confidence interval, you're trying to capture the middle 99% of the population, of the possible sample statistics. So your ensuing 99% confidence interval is going to be wider than, say, a 95% confidence interval. All right, and we'll look at 90% confidence intervals on the next video.